Alright, here's the last thing we're gonna do. This is a instructional video mostly for people who weren't here on what the poster assignment's gonna be, or just a reminder to people who were here. We started in class yesterday a poster assignment. We did some word problems, and then the poster assignment is you're making your own word problem and you're doing a bunch of stuff with that. So I'm gonna read off from my task card that we have. So you and your group, you're going to create a poster, a prototype of your poster on graph paper following the objectives on my task card. I have a PDF already that will be up on Canvas, so you guys will be able to see that soon. With your group, I need to approve your guys' prototype before you get the poster paper, because you're only going to get one poster paper, because poster paper is expensive. Everyone needs to contribute to the poster. Everyone needs to do something. There's plenty of stuff on here that you can divide up evenly. There are 6 parts of the poster that need to be completed, so there should be, everyone should contribute to at least one thing, like at minimum one thing, because there's like groups of 3 or 4 of you. So one person needs to do at least one thing. On the big poster, once you have it done, you're gonna just kind of like initial or like write your name next to parts that you wrote, so I can visually see that. It's just so I can see who did what and just verify stuff. So there's 6 things, as I mentioned. The very first is you're going to write out your word problem, preferably at the top of your poster. Now your guys' poster doesn't have to look like mine at all, but it needs to have everything that's on here. So however you organize it, that's up to you. But it needs to have everything that's on here. You need to have your word problem. Your word problem needs to make sense, or at least in a sense that you can explain if anyone asks you any questions about it. Everyone in your group should be able to explain the word problem, not just one person. The second part is you're describing pieces of information from the word problem as math terms. So like I have over here, I have my word problem, and I have my variables described over here. So X is going to be the cost of pieces of shrimp, and Y is going to be the cost of king crab legs from my word problem. I also have my equations defined. So like my seafood order and my friend's seafood order are both defined as equations. The third thing you're going to need will be to convert your initial equations into slope-intercept form. This is more so of just practice and just knowing how to do it. You don't need to show me any of the work of the conversion, but your conversion needs to be correct. So we're going from standard form into slope-intercept form. That needs to be on there somewhere. Now we'll have, like we've been doing, we've kind of been talking about different representations, talking about tables, graphs, and then showing things algebraically. All that's going to need to be on the graph as well. You're going to draw a table for each equation, like I have over here. Your table has to have at least 5 x and 5 corresponding y values. So all these x and y values, they have something connected to it. It's not just a blank space over there. So you can't have, oh, x is 0 and nothing's over here, or y is 10 and nothing's over here. You need to have corresponding values with each other. There can't be any blanks. Also, on your table, you need to have the solution between the 2 equations. So like as you can see on the table, I have 6 and 2 here, I have 6 and 2 here. That's my solution to these 2 equations. On your graph, you have one graph. You want to make sure it's scaled correctly. So as you can see on mine, each tick mark is going by 1. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on this side. And it's going by the same tick marks. It's going by 1, 2, 3, all the way to 15. Now this one's higher. That's because I just needed a higher y axis, but the scale is the same as my x scale. On your graph, you need to have 2 different lines, which will be for your 2 different equations. There needs to be an intersection point shown, and I didn't label it over here, but you need to label yours, but mine are marked differently, so I know they're 2 different equations. I can identify them by color alone. But I would want you to actually write what equations what, for which line. Finally, you're just gonna solve your system of equations algebraically like we've been practicing the last 2 weeks. You can do it in whatever method you want, but your math needs to be correct, and your method needs to be, you know, something we've done. So like, I solved for x over here by setting the equation, the slope-intercept equations equal to each other, and then I did 2 methods of solving for y. I either plugged it into one of the slope-intercept form equations, or I substituted the x value for one of my original standard form equations. This picture of my poster, without any of these weird edits, I would messed up on it, so that's something I screwed up on, which I don't want you to do. That's why one poster paper, your prototype gets approved by me, so mistakes like this don't happen. A picture of this and a PDF of the poster instructions will be on Canvas at some time today. This assignment is worth 2 assignment grades, so it's total 10 points, and everyone needs to contribute. Everyone. If none of you guys work on it, then no one gets any points. If one person works on it, then they'll get their points and no one else will get their points. So everyone needs to contribute. It's going to be due at the end of class on Tuesday. So if you weren't here on Thursday, well, I mean, you'll get caught up on Tuesday with wherever your group is. I think I'll also post the groups. It should be the same for 5th period, but 7th period I had to move some people around, so I'll probably post those as well. So maybe you can contact people who are in your group. Okay. I'll see you guys all on Tuesday.